any number can be written as some other number squared. So if I have 4 times 4 and I have an area of 16 here, I can say 16 is just 4 squared. Okay? It's just the square root of 16 squared. Now, we don't need to have perfect squares for this to be true. Let's say we have 4.5 times 4.5. Well, that gives us an area of 20.25. 20.25 is just the square root of 20.25 squared. Okay, so any number can be written as its own square root squared. Now, with that in mind, we are going to talk about a subtraction problem where we have x squared minus a squared. That is going to be our problem, x squared minus a squared. Okay, so I've got a series of pictures here for you. Come around this side. So first of all, we have x squared. Okay, x times x makes x squared. It's going to be this large square here. This dotted square just represents that x squared, so you can see that a squared is something smaller. Okay, a squared is a by a. Now, if I want to say x squared minus a squared, it could be this picture here, the larger square with that little one missing. So this would be x squared minus a squared. That would be a subtraction image of this expression. However, I want to turn this subtraction image, where we have this kind of weird, square with a bite out of it, into a multiplication image. So the way that I'm going to do that is I'm going to take this little rectangle here. If you think of a larger rectangle and a smaller rectangle, I'm going to take this one here, just drawn by this little dotted line, and I'm going to move it to the right side. So we're going to take this and we're going to move it up here. Okay, so what that means is that when we move it, we have a new image here. We have a side length of x plus a, because we took this little length a and we rotated it up there, so that a is now up here, x plus a. And this one that used to be a full x has now lost a length of a, so we have x minus a, which I wrote on the right side. Okay, so now we have the multiplication of x plus a times x minus a. We've taken a subtraction and we've turned it into multiplication. Okay, so visually, that is what is happening when we do something that's called the difference of squares. Now, let me give you an example of that without representing those areas as little bites out if they're negative. We're just going to keep track of the value of numbers. Okay, so let's look at this one, x squared minus 81. So we're saying a subtraction problem. We're going to turn this into two squares. So x squared is already a square, but we're going to think of 81 as 9 squared. So we have the difference between x squared and 9 squared. The way that we get that is by doing x plus 9 times x minus 9. Just like before when we did x plus a times x minus a, here we end up with x plus 9 and x minus 9. So our x's make x squared, our 9's make 9 squared with a negative in front. We get negative 9x's in this box, positive 9x's in that box, which cancel out, leaving us with just what we wanted, x squared and negative 9 squared, or negative 81, the expression at the beginning. So we've taken this subtraction and we've turned it into the multiplication of x plus 9 times x minus 9. Okay, our zero product property tells us that the only way for this product equals 0 is if the left or the right side equals 0. So we can do that by making x negative 9 or this second x positive 9. Okay. Meaning our solution is plus or minus 9.